Hey guys, so I'm going to do another quick video on the stuff we'll be doing in class, and this time we're working with encryption. So as we said in class, we've got the plain text, and the plain text is the text that we want to encrypt. So like the message to hide. Now we want to convert that, oops, Mr. Ned, we want to convert that into a cipher. Right, sorry, there's different spellings of cipher. I'm going with the one that the GCSE uses. You can use the American one or the British one. I'm not sure which is which. Doesn't really matter. Now, with a cipher, we have a key. Yeah, so we have our alphabet, which is going to be like, and our little array that has A, B in order, and C, and so on for as long as you like. Dot, dot, dot. And we're going to have a key. So A is going to equal, in this case, A is going to equal R. Don't know why, I've just decided. B is going to equal S. And C is going to equal E. Okay, so if I had a message that was ABC, it would be converted to RSE. And so this is our plaintext, this is our key, and this is our cipher. So the first little thing we're going to do, or like the first step, is we're going to make a key generator, okay? Because I don't want to have to, I could manually come up with the key by myself, but generally speaking with encryption, the more random we can get stuff, the better it's going to be. So let's make a key generator. Okay, so first thing is I want to make the alphabet. Now with this alphabet thing, I'm going to be using ORD and char. Now, if you don't know about ASCII or Unicode, then I'm not going to go into it in this lesson, but we should be familiar with this, that basically every letter has a number. And so I think, for example, that A is what, 97? And then B is 98, and C is 99, and so on from there. Let's just check that and see. So I'm going to print ORD with the character A. Now, very important, lowercase and uppercase are not the same. This is going to be key gen 1. Okay, now if I run that, 97. So an A is equal to 97, and then a Z is going to be equal to 28 times that, or 28 plus that, sorry, 122. So we're going to go from those things. But again, just remember that a capital letter is not the same. So we're just going to work with small letters for this coding system. You can be more advanced later if you so feel. Okay, so let's make our key generator. So I'm going to have the alphabet from A to Z. So I could manually type it out, and I could say alphabet equals da, 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 A, B, C, whatever, all the way through. It's a bit slow. Let's program it. Let's do for X in range. Now we said 97 is an A, through to 123, because remember the last number is not counted. We are going to alphabet dot append, and we're going to append the CHR, the character version of the number 97, or the number X. Again, if you're not familiar with for loops and stuff, I don't want to go into it in this video, but hopefully that will give us what we want. Now if I print the alphabet, just to check what I'm getting out, and I run it, yay, I've got the letters through from A to Z, now added to my array, or to my list, whichever you prefer. Now, Python and other languages have a very nice random function. So I'm going to import random. And what I'm going to do is, instead of printing the alphabet, I'm going to shuffle it. So I'm going to print the alphabet, and then I'm going to do random dot shuffle, shuffle, and then alphabet. Now, what does this do? This is basically a little function that Python has in it, or the random library has in it, that's going to mix up my letters for me. Or it will do it with any array, but specifically in this case, I'm going to mix up the letters of the alphabet. And this time when I print alphabet, I should end up with my key. So this is going to be my key here now. So A is going to equal P, B is going to equal G, C is going to equal O, D is going to equal da-da, all the way through to that. And I'm just going to copy that out of there, Control C, and I'm going to use that in the next part of the program. Okay, so this is our key generator for our symmetric encryption. Alrighty, I'll do the next video, or the next step as another video. See you in a bit.